Hey guys, hope everybody's doing okay. I'm not going to be able to Zoom with you guys today for various reasons regarding the snow and people working and my kids at daycare and all sorts of crazy stuff going on. So I'm going to make a quick video for you here to get you started on today's assignment. It'll be really quick and easy, and then you'll be able to watch this and you'll be fine. And we can talk about it on Friday when we get to class if you're still confused on anything. Okay, so on the roadmap there's a worksheet called Valence Electrons and Lewis Dot worksheet. I want you to open that up, and I'm just going to walk you through a couple of them to get started here. So this is what the worksheet looks like, and this goes back to our lesson on the last time we had class where we had to look at something called a Lewis dot structure and valence electrons. So there's a bunch of elements on the left-hand side in that column. I'll just pick and choose a couple of them here for you, and we'll work through how we solve these things. So let's do lithium. Let's do that one first. Okay, so you're going to find lithium on the periodic table, and the symbol is Li, of course, and you want to see where the valence electrons are going to be, the main energy level the electrons are in, and how many they have. So I have a periodic table. It's not the greatest, but it's here. Okay, here's my periodic table. Lithium is located here, right there where I circled that. Okay, and remember, on your periodic table, I think it has the energy levels on the side, like that. So remember, that's the energy level that you're in. Lithium, if you were to write lithium's electron configuration, it's 1s2, 2s1. And you guys know that from our class on Friday, or last time we were in class, I would have asked you what's the outermost level the electrons are in. And we were very good at this. We said it's level 2. Well, remember, the shortcut for that is to see where lithium is and to just see what level it's in. So it's in level, the valence electrons are in level 2. So we're going to put main energy level for the valence electrons, that's key here, is level 2. Let's write that in. And it says how many. So let's go back here. And remember, everything in the first column has one valence electron. You can see that right here. It ends in 2s1. The first level, that 1s2, those two electrons are in a lower level. So the 2s1, that one electron, is in a level on the outside. So we have one valence electron. So how many? 1. Lewis dot structure. We put our symbol, Li, and then 1 dot. It doesn't really matter where you start putting your valence electrons around it, but remember the max is 8, and we fill up each side individually first until we have to double up. All right. Now the last two columns, you're only going to do one of the two depending on what you have. It says to achieve a full valence shell, number of electrons gained or lost. Lithium has one valence electron, so it has two options. It can gain 7 more to become like neon. And this periodic table I found online is inaccurate. Okay, helium is so small it only has 2 valence electrons. So that's an exception to our rule there. That bothers me. So lithium could gain 7 more electrons to get an octet, or it could simply lose 1 electron to be like the nearest noble gas, which is helium. Okay, if lithium loses this electron, we're down to 1s2, and that is helium, a noble gas. That's helium's electron configuration. So number of electrons gained, not going to happen. Number of electrons lost, 1. Okay, let's do magnesium. Yeah, let's do magnesium. Okay, let's erase some of this here. Okay, so magnesium is going to be here on the periodic table, right there. So if you go to our previous example and work through it the same way, you can see how easy this is. The main energy level for the valence electrons is level 3. Okay, we're right here, so it's level 3. How many valence electrons does it have? We're here, so it's in the second column, so 2 valence electrons. Lewis dot structure, you put the symbol, which is Mg, 1, 2. Okay, it's a little sloppy, but there's 2 there. Finally, oops, wrong way. Finally, is magnesium going to want to gain 6 more electrons or lose 2? Well, metals tend to lose electrons. I always say metals are losers. They lose electrons. They would prefer that. So magnesium is going to lose 2 electrons. If it loses this one and this one, all of a sudden it is just like the electron configuration for neon. So it is going to lose 2 electrons. All right. Let's do one more, and I'll let you guys do the rest. Let's do lead. All right. I did this one in my class yesterday. Let's do lead. Lead is Pb. Gotta find it on here. It is, let's see, 1, 2, 3, 4. Right here, I think. Again, I'm looking at the periodic table on the wall behind my computer screen, if you're wondering what I'm staring at. There's Pb, and the energy level the electrons are in, the valence electrons, is level 6. Okay, so let's go ahead and put level 6 there. How many? It has 4, right, from our pattern the other day. So our electron configuration, or I'm sorry, our Lewis dot structure, Pb, 1, 2, 3, 4. This is a little tricky, all right? Keep going the wrong way. You have a staircase here. I think we talked about that before. The staircase divides your metals and your nonmetals. All right? So the metals are over here and the non-metals are over here. Metals prefer to lose electrons. Non-metals prefer to gain. Okay, so metals prefer to lose. Non-metals prefer to gain electrons. Okay, so you have to ask yourself, okay, we have lead here. Lead is a metal. It's underneath, it's in the metal section. It prefers to lose electrons. So it's going to prefer to lose 4 electrons. If you have something else in that column that is like, that's a non-metal, like carbon here, that would prefer to actually share electrons. It's kind of weird. It doesn't really lose or gain. The carbon's a weird one. It prefers to share electrons. So you could say it could prefer to gain 4. So it has its octet that way. But those are some rare examples there, because most of it's going to be pretty straightforward, where you're over here in this section, right, where you're going to lose electrons, or you're over here in this section where you're going to gain electrons. All right. Remember, the noble gases, these guys here, they don't gain or lose. They're good how they are. Okay, that takes care of it. So what you guys want to do is finish this page, and then there's another page. I only took a screenshot of one of them to get you guys started. And finish this. It won't take you long at all. You're talking 10, 15 minutes maybe. You want to finish that and show it to me in class on Friday for a little like homework check grade. Okay, so finish it up. Do today while you're here, and then you'll be good to go. All right, thanks guys. See you later.